Yeah, what's up guys, welcome to question 8 of June exam 2025 grade 12 paper 1. I am Gastin Mapala. Let's have a look at this question. Has got 3 questions, 1.8.1 to 8.3. Alright, so the first question here says that determine f prime x from first principle given that f of x is equals to x squared minus 2. Okay, 8.1 here we are given f of x prime in terms of is going to equals to lim as h approaches 0, and then we're going to have f of x plus h minus f of x all over h. Great stuff. So now when we come here where there's x, we're gonna put here we must continue writing f lim until such time that h approaches 0. So where there's x, we're gonna put this number here. Where there's x, we're gonna put x plus h, but the x is squared, therefore we're gonna square it, and then minus 2, therefore minus the whole f of x, which is in brackets x squared minus 2 close bracket, all divided by h. Okay, as you can see now, we just have to expand then simplify. Guys, for here you're gonna get a mark for substitution, and then let's come here, x plus h, x plus h, therefore minus 2, then we can might as well remove the bracket here and multiply throughout. Negative x squared, negative times negative 2 is going to be positive 2, therefore all over h. Okay, lim as h approaches 0. Here we can multiply throughout binomial to remove the brackets. It is going to be x squared plus 2xh, therefore plus 2 plus h squared rather. Then you've got a minus there, you've got a minus x squared plus 2. Now if you have a look at this, all over h, here we've got like terms, x squared would cancel with x squared, then you've got minus 2 and then plus 2. Therefore what we left with now, we are left with lim as h approaches 0. We are going to be left with 2xh plus h squared divided by h. Therefore, as you can see at the top, we've got a common factor of h, so therefore we can remove that h as a common factor. I'm going to continue here. H approaches 0. Remove h as a common factor. When you remove h here, we're going to be left with what? 2x plus, you remove h from h squared, you're going to be left with h all in brackets divided by h. H from the bottom will cancel the h at the numerator, therefore you are left with 2x and h approaches 0 here. So our answer in this case, f of x prime, will therefore be equal to 2x. Right, correct. All right guys, if you're following, please let me know on the comment section below, or if you like what you see, give us a like and then share this video with your classmates, your friends, and everyone that needs it. 8.2.1, they are asking us to take a derivative from the first principle. They want us to find d of dx in brackets 3x squared minus 4x. All right, so therefore here we can just take the derivative straight away because this question here is already simplified. Okay, we're gonna come here and say you drop, remember first principle is this one guys, is the one where you need to drop the exponent then minus 1 from that exponent when you take the derivative. All right, so we drop the exponent, is going to be 3 times 2, and then we minus 1 from here, which is going to be 2 minus 1 is going to be x, minus, we drop the 1 4 times 1. Therefore, x to the power 1 minus 1 here is going to give us 0. So therefore here 3 times 2 is going to be equals to 6x. Then therefore 3 times 1, anything to the power of 0 is equals to 1. So therefore 1 times 1 times 4, it is going to give us minus 4. And that's our answer there. Therefore 8.2.2 8.2.2, they want us to find the g of x prime, which is the derivative. Okay, and then they are saying it is given to us in terms of this g of x, it's equals to -2 square root of x in bracket x minus 1 all squared. However, here we can't take the derivative straight away because we've got a problem there. We need to simplify our equation first before we can take the derivative. So it's going to be minus 2 here, x to the power of 1 over 2, and therefore here we can expand our bracket. Then we do the simple algebra, binomial, first times first, last times last, x squared, that minus that is going to give us the total minus 2x. Therefore -1 times -1, +1. Thank you guys. Right, so now here we can multiply throughout. -2x to the power of half times x squared, -2 will remain, and then you're gonna have here, we have here half, we have got a half plus, we have a half plus, okay, I'm freezing now. Okay, great guys. You're gonna have a half plus 2. Half plus 2 is going to give us x 5 divided by 2. When you remember now guys, here I'm using the exponent rule. If you are multiplying, the bases are the same, you add the exponent. I'm using this rule here guys. If you are multiplying, the bases are the same, what do? You add the exponents, plus 1. Right, so even here you're gonna do the same thing. -2 times -2, +4, and then you say half plus 1 is going to give us 3 over 2. Then -2x to the power of half times 1 is going to be -2x to the power of half. Great. Now that we got this equation in the linear form, now we can go ahead and take the derivative from definition. Right, so you can come here and say drop the exponent. Okay, -2 times 5 over 2. Okay, then x, then minus 1 from the exponent. I'm gonna be left with, when I minus 1 from the exponent, I'm gonna be left with 3 over 2. Therefore plus 4, drop the exponent, then minus 1 from the top, x. Then when you minus 1 from here, from 3 over 2 is going to give us half. And then the same thing applies here. Drop the exponent, 1 over 2 minus half. Then it's going to be x to the power of -half here. Great, now we can just simplify further here. Let's go, let's see now. 2 and 2 would cancel out. You're going to be left with what? -x to the power of 3 over 2. No, sorry, you're going to be left with 5. Okay, let's see. I'm forgetting the 5 there. Going to be left with 5x to the power of 3 over 2. Then half here, cancel 2. You're going to be left with 6. It's going to be plus 6. We're going to have plus 6 x to the power of half. And therefore here, 2 and 2 cancel out, -x to the power of -half. Right. And that's how you deal with the questions like this one on a derivative. If you've got any question, drop it on the comment section below. Let's move on to 8.3. Now 8.3, quite an interesting one. typical November question here. I think here the examiner is trying to give us a glimpse of how will they be asking questions in November, guys. So please take note of such questions. Right, so let's read the question. Said given here it's a y is equals to 4x minus 14, which is a common. That's very key right there. It's a common tangent. It's a common tangent to this function here and also to this function here. Now they want us to calculate a and b. Right, so just to put this into perspective, or just to visualize it, this tangent is touching the two graphs. So it's already, you can see this one, a is greater than 0, so therefore you can see that this is a smiling hyperbola. Right, so you have got that here as our function. So this is a smiling parabola, I mean to say. So you have got this. It means it's only touching at one point, because they said to us it's a tangent. So if you have a look at it there, okay, this parabola is not make sure. There you go. So this one will be the f of x. Right, so now it means the g of x should be touching here only the one point as well, because they said it's a common tangent. It means these graphs are all passing from the same point, because they have got the same common tangent at a given point. So this is the point here. So now what can we do first? Remember, if this is a point here, if you can say y, this straight line, it's equals to f of x at that particular point. However, this, you can work it out that way, but the problem with this one is that you're going to have two values of x. Therefore, you need to decide which one you are going to use on the equation going forward. However, because now we're dealing with calculus, we know that the first derivative of any function is going to be equal to the gradient. That one we know for sure. Okay, so now if it's equals to the gradient, so now at this point, so we can say, because we already know the gradient of this straight line, which is also the gradient when you derive this function, we can therefore equate them together. So let's find the derivative of f of x. Okay, so the derivative of f of x, you drop the exponent, 4x minus 4 should be equal to the derivative of the tangent, which is 4 there. So now let's go ahead and try to find what is our x value. In this case, we have 4 plus 4, which is equals to 4x is equal to 8. Then you divide by 4 both sides, divide by 4, divide by 4. Therefore our x value is equals to 2. Right, so now you have got 2 there as our x value. Now how can we find the y value? The y value, we can simply find it by substituting the x value into the tangent equation. So therefore tangent equation is given by x, 4x minus 14. So now we can substitute our value there, minus 14. So now here you've got y is equals to 8 minus 14, which gives us how much? Which gives us negative 6. Right, so the value here is equals to negative 6. So now that we have that, now we need to come here into this equation. First thing first, if this point lies on the both equations, you can clearly see that given this point, we can substitute it into our equation a g of x. Right, a g of x, a squared, because as you can see there's a and b there, so most likely we're going to have to deal with this simultaneously. So now if we can come here and say if x is equals to 2 in this graph, y is equals to negative 6. So y is equals to negative 6 provided that x is equals to 2. So let's go ahead and do that and see what we come up with. Minus 18, take 18 to the other side, gonna have negative 6 plus 18 is equals to 2 squared is equals to 4a and therefore also 2 times b is equals to 2b. So here what are we gonna have is gonna be 18 minus 6 plus 18 is going to give us 12 is equals to 4a plus 2. So we can call this our equation 1, right? So now, but however, what can we do next? However, we can, because we know that at this point we also have the derivative at the same point. Now we can come here and say, okay, now let's find the derivative of g of x, which will be equals to also the gradient of the tangent, which is going to be equals to also the gradient of the tangent, which is what? In this case, the gradient of the tangent, which is equal to 4. So the derivative there, if we take the derivative there, is going to give us 2ax. Then you drop the y exponent there plus 4b, and then it's equals to the gradient. Okay, is equal to the gradient. However, you must remember that we're getting this gradient when what? When our x value is equals to 2. So therefore you can also come here and say, okay, now this gradient we get it when the x value is equals to 2. So you can put here where this x is gonna be 2 times a, therefore plus b is equals to 4. So now what are you gonna have? You're gonna have 4a plus b is equals to 4. Then this will be our equation number 2. So now we've got these equations here together. Let's put them here. 12 4a plus 2b, and then we have got here also 4 is equals to 4a plus b. Now this is our equation 1, this is our equation 2. You can solve this simultaneously, guys. You can make one the subject of the formula of the other, it will still be the same. Or what you can do in this case, you can simply just say equation number 2 minus equation number 1. The answer should work out until the same. So here we're going to have 12 minus 4, then we're going to have 4a minus 4a, which is 0, then 2b minus b gives us b. So therefore here when we minus 4, we're going to be left with 8. b is equals to 8. Therefore, in order for us to find a, we just have to substitute b back into equation 2 or equation 1, it doesn't matter. Then we should be able to get the answer there. So it's going to be 4 is equals to 4a plus b. We already know that b is equals to 8 plus 8. Then you move 8 to that side. 4a is equals to it's 8 will change the sign. 4 minus 8. In this case, you're going to have 4a is equals to negative 4. Therefore, a is equals to 1. Negative 1, I mean to say. As we can see, then it makes sense if a is equals to negative 1, because it means it's a concave down. There, because our a value is less than 1, then the graph is looking down. And this was a very interesting question with 6 marks. Let me know what you guys think, if I can do better, or you guys really enjoy the content. Give this video a like, and I will see you in question 9.